In 2013, Voyager 1 achieved a historic milestone by becoming the first human spacecraft to enter interstellar space, completing the feat 36 years after leaving Earth. The current observatory is 14.5 billion miles from Earth, causing messages to take approximately 20 hours and 33 minutes to be sent and received. NASA experts did not expect Voyager 1 to continue space exploration for more than 6 months, but the vehicle exceeded expectations, having discovered 500 unknown objects in space. Now, world-famous podcaster Joe Rogan has joined the discussion to share the incredible results of this extraordinary discovery. What are these mysterious objects? Are they related to aliens or a malfunctioning plane? Join us as we explore how Voyager 1 detected 500 unknown objects floating in space and discover Joe Rogan's incredible findings. Have you ever wondered why, despite the unimaginable vastness of the universe, we do not pursue real evidence of alien civilization? This problem is called the Fermi paradox and has fascinated scientists for centuries. However, a recent encounter in the depths of space has surprised scientists and may shed light on the age-old question of whether aliens exist. Joe Rogan, an expert and podcaster known for discussing aliens and the possibility of extraterrestrial civilizations, has previously hosted guests like David Grush and other researchers on the possibility of life beyond Earth. Now, new data from Voyager may finally be the key to answering the question of whether we are truly alone in the universe. Buckle up as Joe Rogan explains why Voyager 1's announcement that it has detected 500 objects traveling through space is a game-changer and how it can impact you, no matter where you are in the world. But before we get to the fun part, let's understand how Voyager 1's mission happened. Isn't it surprising to think that our wonderful world, with its endless oceans and towering mountains, is just a small part of the bigger universe? Scientists have wondered about this for centuries, but it was not until the 1970s that NASA scientists had the opportunity to understand the scale of our cosmic community. It all started with the unexpected conjunction of the 4 largest planets in the solar system: Jupiter, Saturn, Uranus, and Neptune. Amidst the celestial dance, a medical student named Gary Flandreau, who worked part-time at NASA's Jet Propulsion Laboratory while studying at Caltech, came across a highly surprising discovery. By carefully calculating and plotting the orbital paths of the giant planets, Flandreau discovered a phenomenon in the sky that would revolutionize space exploration. Flandreau's findings were nothing short of encouraging. In the late 1970s and early 1980s, these 4 planets were tracked in a fascinating arrangement like pearls in a cosmic necklace, with Earth among them. This discovery created excitement at NASA because it offered an unprecedented opportunity to improve space travel by using the gravitational assists available from each planet. A spacecraft could propel itself forward using a force similar to the pull of invisible cosmic strings. Flandreau's predictions suggested that gravitational assists from the giant planets could reduce the flight time between Earth and Neptune from a daunting 30 years to just 12 years. However, there was a catch. This magnificent alignment occurs only once every 176 years. Recognizing the importance of this once-in-a-lifetime opportunity, NASA embarked on a mission to explore the planets. 2 spacecraft, Voyager 1 and Voyager 2, were built with the same design and mission, launched 15 days apart in the summer of 1977. The twin explorers aimed to uncover the mysteries of the solar system and beyond. Voyager 1, launched on September 5, 1977, became a key part of the Voyager program, a testament to humanity's curiosity and quest for knowledge. For nearly 50 years, this incredible spacecraft has continued to travel, bringing valuable data back to Earth via NASA's Deep Space Network. It has become our eyes and ears in the vastness of space, bridging the gap between our known world and the unknown beyond. While marveling at Voyager 1's incredible journey, it's worth noting that it's only a breath away from Earth. As of August 2023, the observatory is an astonishing 14.5 billion miles from our planet. Carefully designed and built by the brilliant minds at NASA's Jet Propulsion Laboratory and powered by the Titan III launch vehicle, it began its adventure from Launch Complex 41 at Cape Canaveral Air Force Station. Now, let's take a deeper dive into this amazing expedition of 500 unknown objects floating around in space and the fascinating explanation Joe Rogan recently gave on the Joe Rogan podcast. How did Voyager arrive in interstellar space? Imagine a space explorer venturing into the great unknown and conquering the vastness of deep space within a decade. That's Voyager 1 for you. This brave spacecraft is already an incredible 14.5 billion miles from our planet. Take a moment to think about this. This distance is equivalent to traveling approximately 3.6 times the length from Earth to the Sun in 1 year. But there's much more to Voyager 1 than speed, distance, and longevity. It also delivered a big reveal, including the recent discovery of 500 unknown objects hidden in the vast expanse of space. This finding is unlike anything we have seen or analyzed before. It is a treasure trove of cosmic mystery and wonder, and we are about to unveil the details of this revelation. You may wonder how a spacecraft launched in 1977 is still operating and providing such exciting information. The answer lies in the excellent engineering and vision that went into Voyager 1's design. One of the main secrets to its longevity is the presence of 2 backup computers. Voyager and its twin, Voyager 2, are equipped with 2 computer subsystems, the Flight Data Subsystem and the Attitude and Articulation Control Subsystem. This redundancy is an ingenious move that ensures the flexibility of systems and the ability to activate computer components when needed, prolonging their lifespan. The computer system on the Voyager spacecraft is configured as a distributed system consisting of 3 dual redundant computers. This intelligent planning ensures that even if one of the systems fails, the others can manage the mission smoothly, preventing the main goals from being compromised. To make the most of limited power consumption, Voyager devices rely on wired logic. In other words, computer systems are designed with complex algorithms that operate within energy budgets and time constraints. Power management during spacecraft construction was a crucial factor in maintaining operational integrity. Voyager 1's distance from the Sun poses a significant challenge to its ability to harness solar energy effectively. To maximize energy efficiency, engineers had to find innovative ways to optimize energy use. One such strategy involves prioritizing power for critical processes. Engineers carefully examined components or subsystems that were non-essential to the mission. For example, the heaters of some scientific instruments were disabled. These heaters were designed to ensure that the equipment was kept at a certain temperature for efficient operation. When turned off, they reduce energy consumption, extending the overall service life of the spacecraft. However, decisions about power management for critical processes are not taken lightly. They involve a comprehensive analysis of trade-offs between energy savings and mission objectives. Engineers work closely with scientists to ensure that removing certain procedures does not compromise the quality and usability of scientific data. The goal is to strike a delicate balance that maximizes energy efficiency while maintaining critical performance. Voyager 1's power management system can adapt to changing environments. As the spacecraft moves away from the Sun, solar energy decreases. But Voyager 1 adjusts its power consumption accordingly, ensuring sufficient resources to support critical operations and data transmission. It's like having a smart energy saver on board. Over the years, significant technological advances and improvements have been made in power management. Engineers continue to refine Voyager's power utilization through enhancements such as increased power delivery, improved battery charging systems, and sophisticated electrical and thermal management. Thanks to these effective energy management strategies, Voyager 1 has exceeded all expectations. Almost 6 months after its launch, it continues to provide critical insight. Considering that this spacewalk was first conducted only 5 years ago, the longevity of it is truly surprising. It speaks volumes for the dedication and creativity of the scientists and engineers who work tirelessly to operate Voyager 1. But let's not forget, the depths of space are full of surprises. So hang in there because more discoveries are coming. Designed to explore the vastness of the solar system and beyond, the Voyager mission is equipped with an impressive array of electron instruments and systems. These instruments were nestled into the spacecraft's fuselage, consisting of 65,000 individual parts. Although Voyager began its interstellar journey with a variety of functional devices, only 4 remain operational on Voyager 1 and 5 on Voyager 2. One of the long-term instruments aboard Voyager 1 and Voyager 2 is the low-energy charged particle instrument. This device features 3 sets of particle sensors that measure the number and speed of low-energy particles hitting it, tirelessly observing cosmic radiation and detailing the sun, planets, and interstellar space. A companion instrument, the Cosmic Ray Instrument, actively searches for high-energy particles from the sun and other galactic sources. Cosmic radiation instruments now detect materials emitted from the vast interstellar space and the protective bubble formed by the sun's influence. These readings proved crucial in determining when Voyager 1 entered interstellar space. It is worth noting that the device is still operational on both Voyager 1 and Voyager 2. Featuring 2 long antennas at right angles to each other, the plasma wave subsystem is a vital tool for measuring the electromagnetic field of potentially undiscovered exoplanets. However, its role evolved as Voyager entered interstellar space. Today, the device provides information on how plasma waves change as they travel through space. Moreover, magnetometer behavior studies make influence or each other are mutually and non-originally designed to study the magnetic fields of outer planets. The magnetometer now plays an important role in investigating the transition zone between the Earth's outer core and the central core. Scientists use this instrument to explore the magnetic properties of the changing region, where the sun's magnetic field interacts with magnetic material on the sun's surface, providing insights into how planets' magnetic fields evolve over time. It is noteworthy that the magnetometer remains operational on Voyager 1 and Voyager 2. Another crucial instrument is the plasma probe, which identifies the lowest energy material in the plasma environment. It can discern objects moving at certain speeds and determine their origin within a specified range. These resources become increasingly important as spacecraft venture deeper into space. However, it's important to note that the current measurement only functions on Voyager 2. Although some of Voyager's instruments have been intentionally or spontaneously turned off to conserve energy, the plasma research instruments on Voyager 2 continue to prove valuable for scientific research. Additionally, in an effort to conserve energy, NASA installed heaters on both spacecraft in 1998. Each spacecraft can have up to 3 radioisotope thermoelectric generators, RTGs. These generators use the heat generated by the decay of plutonium-238 to produce electricity. However, as plutonium-238 continues to decay, it will eventually no longer be able to provide power, leading to the eventual shutdown of the entire device. This is expected to occur around 2025. Each Voyager probe is equipped with 2 thrusters, not to propel the spacecraft forward, but to reposition the antenna so that it always points towards Earth. This challenge is necessary to maintain communication with the spacecraft. The thrusters emit short pulses or jets lasting only a few milliseconds to precisely rotate the spacecraft and orient its antenna towards Earth. In November 2017, due to the degradation of Voyager 1's main thrusters, scientists activated the backup thrusters. This operation enabled Voyager 1 to re-establish contact with Earth after nearly 4 years of silence. Remarkably, the backup thrusters are capable of powering up and supplementing the spacecraft's antenna, even if it remains inactive for extended periods. The main transmitter of the Voyager probes emits approximately 20 watts of power, comparable to the light emitted by a refrigerator bulb. By the time the Voyager signal reaches Earth, its energy has weakened by 20 billion times compared to a digital watch battery. Despite the amazing performance of the Voyager spacecraft since its launch, it's worth noting that your iPhone has 100,000 times more memory than the Voyager spacecraft. Now that you have a better understanding of Voyager's mission, buckle up as we delve into the history of the 500 mysterious objects recently discovered in space. The data sent by Voyager 1 was initially inaccurate, attracting the attention of the scientific community. With its latest discovery, a space probe stumbled upon a peculiar find: 500 unknown objects lurking in deep space. This discovery has raised concerns among scientists because these mysterious objects remain enigmatic. Most importantly, the initial information relayed to Earth was garbled, akin to a distorted message from afar. Imagine the surprise on the faces of scientists at NASA's Jet Propulsion Laboratory when they realized they had retrieved this baffling substance from the far reaches of space. After thorough investigation, the source of confusion was traced to the Attitude and Articulation Control Subsystem, AACS, an integral part of Voyager 1 responsible for measuring, reporting, and correcting the spacecraft's orientation in space. The AACS is equipped with antennas pointed towards Earth to transmit data back to our planet. Researchers recently discovered that the AACS had been using an incorrect computer, which had been dormant for years, causing interruptions in telemetry data. NASA engineers swiftly rectified the issue by reconfiguring the AACS to accurately transmit data from the correct computer. As a result, Voyager 1's telemetry data is now flowing back to NASA scientists as expected. However, the lingering question on everyone's mind is why the AACS was utilizing the wrong computer. Although NASA scientists cannot yet provide a definitive answer, they speculate that the AACS received erroneous commands from another onboard computer. Nevertheless, the exact computer responsible for this anomaly and the nature of the discrepancy remain unclear. Suzanne Dodd, project manager for the Voyager interstellar mission, shed light on the AACS situation by stating that a thorough memory dump will be conducted, followed by a comprehensive analysis of its operations. This diagnostic feature is designed to pinpoint the root cause of telemetry issues. Furthermore, NASA's Jet Propulsion Laboratory affirmed that the AACS is now operating normally and the spacecraft remains safe. Consequently, Voyager 1 was not forced into safe mode, and there was no compromise in signal strength. Although several factors contribute to such glitches, one of the most significant challenges is space's harsh environment. The cosmic realm is notorious for its extreme conditions, which can pose serious challenges to spacecraft operations like Voyager 1. The spacecraft's instruments are vulnerable to cosmic radiation, temperature fluctuations, material degradation, memory errors, and data corruption. Additionally, temperatures in space can plummet to a bone-chilling -270 degrees Fahrenheit. Furthermore, Voyager 1 is exposed to micrometeoroids, dust, and debris from asteroids and comets, which can potentially impact its mission. As the spacecraft journeyed deeper into interstellar space, the plasma wave detector consistently detected the effects of dust particles due to their high radial speeds of 17 kilometers per second. When a dust particle collides with the spacecraft, it instantaneously vaporizes and ionizes, creating an expanding cloud of plasma that generates strong pulses on the plasma wave subsystem's antenna.